We're going to talk about finding the x-intercepts and y-intercepts and vertex of the graph of a parabola. Question A says, what is true about the value of y for all x-intercepts? Well, x-intercepts are on this axis here where it will cross, and so the y value would be 0. Or in reverse, what is true about the value of all x-intercepts? Oh, the value of x for all y-intercepts. So the y-intercept would cross the y line, and the x-coordinate here would be 0. Question B. If x equals 0 at the y-intercept, find the y-intercept of the graph y equals 2x squared plus 5x minus 12. So we know the x should be 0. So we can plug in 0 for the x's. 0 squared is 0 times 2. This is still 0. 5 times 0 is 0. And minus 12. 0 minus 12 would be negative 12. So the y-intercept is at negative 12, and we're going to write it as a coordinate on the graph that it's 0, negative 12. Since the x-intercept occurs when y is 0, write the equation that you would need to solve to find the x-intercepts. So in that case, we would want to change the y to be a 0. So we have 0 equals the 2x squared plus 5x minus 12. Right now, you don't know how to solve this, but we're going to learn. Part D, the roots or zeros, or x-intercepts, of the quadratic are the values of x that make the value of this quadratic equal to 0. An x-intercept of a quadratic is a root. At this point, do you know how to solve it? No, but that's what we're going to learn now. So all we're going to do is we're going to take this equation and we're going to start by factoring it. I'm going to make the box and diamond problem. 2x squared and negative 12 go in the diagonal. If we multiply those together, we would get negative 24x squared. And we want to pick two numbers that will add to positive 5x. Got these and these, and then this one. The numbers that would work here are positive 8x and negative 3x. Those would multiply to 24, negative, and they would add to 5. So we'll put in 8x and negative 3x, and we'll look for those common factors that we can take out. So 2x by x, and then negative 3 times 4. So our factoring is going to say x plus 4 times 2x minus 3. Doesn't matter what order you put your parentheses in. But now we're not done. All we did was factoring. What we're trying to do now is find the x-intercepts, or the roots, or the zeros. So we need to make this equation equal to 0. And the new idea is called zero product property. Anything times 0 is equal to 0. So if this first set of parentheses, I could make it a 0, 0 times anything else in the next parentheses would still be 0. So we're wondering what number could we plug in so that this first parentheses could make a 0. When would x plus 4 make 0? Well, we can minus 4, and we'd get x equals negative 4. There's one of our x-intercepts. And I could check it. If I plug in negative 4 plus 4 is 0, times whatever's in the next parentheses, it'd be negative 11, would still make 0. We can do that same process with the second set of parentheses. What if this was the giant 0, and this 0 times anything else is 0? So we need to know what number can we put in for x that would create a 0 here. 2x minus 3 has to make 0. We would add 3 and divide by 2, and we get 3 over 2, or 1.5. These are my two coordinates for my x-intercept. I will write them as coordinates, and then I will graph them on the graph. So I added those x-intercepts and the y-intercept on the graph. And if we drew the graph parabola through here, it would be something like this. Keep in mind the y-intercept is not necessarily the highest or lowest point for the graph. The y-intercept would be directly, or the y-intercept is where it crosses the y-axis. The vertex, which would be the highest or lowest point, is exactly in the middle of those x-intercepts, right in the middle of -4 and 1.5. So somewhere right along here would be that lowest point, which we're going to learn how to find next. So this one asks us, can you make a sketch of a parabola from the two x-intercepts and the vertex? Yes. We're going to start by actually finding the y-intercept, because the y-intercept is what happens if you plug in 0 for the x's. So if we plugged in 0, 0, and 0, that last number, that constant term, is typically your y-intercept. And it is here, so we would say our y-intercept is at 0, -8. When we plugged in 0, we got -8 as an output. Now we can find the x-intercepts. We're going to start by factoring our quadratic using the diamond and rectangle. We'll put in the x squared and -8. If we multiply those, -8x squared. And in the bottom of our diamond problem is what we want them to add to as like terms, which would be -2x. So the numbers that we can pick that multiply to 8 are 4 and 2, so we'll have -4x and +2x. Put those into our rectangle. And we'll take out our common factors. Let's see, this would be x by x, -4 and 2. We'll write it in factored form, x plus 2 times x minus 4. And this factoring is going to help us find the x-intercepts if we write that the equation we now want it to equal 0, because it will x-intercepts cross on the 0 line for y. And then we just look at each set of parentheses. When could each parentheses make 0? X plus 2 has to make 0, and x minus 4 has to make 0. So we'll -2, and we get x equals -2. Or we can add 4, and we'll get x equals -4, or +4. And it's best if you can write them as coordinates to remind you where they would be on the graph. And x-intercepts at -2, comma, gives an output of 0, and 4 gives an output of 0. If we start to sketch this on graph paper, which I don't have, the y-intercept is down here at -8, and those x-intercepts are at -2 and 4. So what we need to do is find the vertex. The vertex is in the middle. So if I work my way towards the middle, exactly in between -2 and +4 is 1. Right through this 1 is the middle. There are 3 spaces to the left and 3 spaces to the right to the x-intercepts. So since this is at 1, I'll even write the 1, that's what we know x needs to be to find the vertex. So we're going to go back to our original equation and plug in that we want the x value to be 1. So we're looking for what is the y output if the x is a 1. So 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8, which is -9. So our coordinate for our vertex will be at +1, because that was the middle of the x-intercepts, comma, -9, because when we plugged in 1 for x, the y output was -9. We can plot that down here, and then we can draw our U-shaped parabola through all 4 points: the x-intercepts, the y-intercept, and the vertex.